Alright folks, I've had a question over the last two, 7 and 8, and the 9-3 assignment. In an effort not to give away what the answer is to those, I will do one that is similar to it. Okay. So the idea here is that we're trying to do these rotations around points that are not the origin. Okay, so the question says, using P as your point or your center of rotation, rotate M 90 degrees counterclockwise to find the coordinates of M prime. So kind of the most direct way of doing this is to take P and relabel P as 0, 0. Now, if P is 0, 0, then we are going to try to figure out what M is off of that 0, 0. And instead of counting, I think the easiest thing to do is to realize that P is now closer to M than, let me rephrase it, 0, 0 is now closer to M right now rather than it was when it was that point 0, 0. Okay, so basically what I'm trying to do here is just find a quick way of finding the new coordinates of M off of this point P being 0, 0. So if I were to count over, this is actually going to be 8, 3. And that's simply just by taking this 11 minus that 3 and that 7 minus that 4. And that will tell me then the distance in the x and y direction that M is from P, okay, which I'm now just going to call 0, 0. If you count, you get 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. I just don't like to do the counting. Okay. So now that we've got this based off of a 0, 0, I can actually rotate 8, 3 now. So a 90 degree, now it's saying counterclockwise. So a 90 degree rotation counterclockwise of A comma B is going to turn into the opposite of B comma A. So my point is 8, 3. It's going to become -3, 8. Okay, and that then would be off of this being 0, 0. So I'm gonna go -3, 1, 2, 3, and then up 8. So it'd be about right there. Okay, just a quick check here. You can draw the lines that go from M prime to P and P to M, and those should be a right angle there. And these distances, if you were to find the slope of that one and the slope of that one, they're going to be opposite sign reciprocals, so that tells us the distances are actually the same. But when I name this point down here in my answer, remember the question didn't know that I was using P as 0, 0. So if you remember what we did, we subtracted that 3 out of that 11 to get this 8. We subtracted that 4 out of this 7 to get that 3. When we rotate, we essentially want to work that back in. Okay? So I subtracted 3 out. I'm going to add 3 back to this. And I'm going to add 4 back to that. And that's where you see now this would be 0, 12. And instead of having to count 0 to 12 right there to get that ordered pair, I've essentially done it with that algebra. Okay. Says do the same thing but rotate 180 degrees. So rotating 180 degrees is going to be, if I have A comma B, it simply turns into -A, -B. So again, I'm starting with 8, 3. I'm going to make it -8, -3. Then we're going to add that 3 back in, and then add the 4 back in. So now -5, 1. If you were to graph that, let me see if I still got this in. I don't have it in GeoGebra still, but I can put it in quickly, I think. Actually, I should be able to. Alright, so those points there are the ones we were using, and we would find out -5, 1. So -5, 1, just using some geometry here. understanding 180 degrees is using a semicircle. It would be 180 degrees would be that diameter. And you see here that P to M and P to A would actually be the same distance because they're radii of that circle. So that's convincing me that I've taken M and I've rotated it 180 degrees around P, and it sat down here at A. And that's really what you're doing when you're rotating a point around another point. Let's say that the point I'm rotating is B, and I want to rotate it around P. Essentially, it's just going to stop somewhere on the circle. Okay, so if I rotate like B now 180 degrees around P, it's probably going to come down to somewhere like that. If I start with this point here and I want to rotate it 90 degrees, it's probably going to end up somewhere maybe like right there. Hopefully that helps. Okay, now obviously the numbers in your problem were a little bit different. So now let's get to this one here. Says use directions above to provide the correct ordered pair for A prime. So I think okay, it says rotate A around P 90 degrees clockwise. Okay, so it says rotate A around P 90 degrees clockwise. Well, if you go through all our rules, none of them talk about 90 degrees clockwise. All of our rules are counterclockwise rules. So if I want to go 90 degrees around P, so maybe that's 90 degrees, what I have to be able to do is figure out, well, how many degrees would that be moving counterclockwise? Okay, well, 90 degrees clockwise is exactly the same thing as 270 degrees counterclockwise. That's the rule that I'm going to use. If you go back to the PowerPoint or the video, it says a rotation of 270 degrees counterclockwise. If you start with A comma B, it's going to turn into B comma negative A. So again, in order to do this though, that rule is for rotating around 0, 0. Well, I'm not doing that. I'm rotating around P. So P here needs to become 0, 0. So now you're going to have to identify what A is off of that 0, 0. So A is going to be -1, and then up 1, 2, 3, 4, 5. So -1, 5 is now the point that I'm going to actually be able to use this rule on. Again, you could have just taken this point of A, subtracted that 6, and you get your -1. Take the 2 and subtract -3. So 2 minus -3 gives you that 5. Okay. When we're done, we're going to think about, well, we just subtracted that out. We're going to do the rule, and then we'll add that back in. So we're taking the point -1, 5, and it's going to turn into, after I do a 270 degree counterclockwise rotation, which is equivalent to a 90 degrees clockwise rotation, 90 degrees clockwise rotation. This is going to become, so I flip them, and then I negate essentially the y value here, so -1 gets negated, becomes +1. So now remember, we subtracted that 6 out of that 5. Okay, now I'm going to add 6 back in, and here I'm going to add 6 back in. Okay, so when we do that, or I guess, sorry, not 6. We subtracted 6 here, so we subtracted that 6 to get that 1. So I'm going to add 6 there. We subtracted -3 to get that 5, so I'm going to add back in my -3. So when I do that, this is going to give me 11, and this is going to give me -2. Okay, and if we look at that, so I'm just going to plot those points real quick. This up, so alright, so we had A was at 5, 2, and P was at 6, -3. Okay, So I'm going to take A, and I'm going to rotate it. It's kind of cheating because this has got the built-in tool for doing this. I'm going to take A, rotate it around P. It says 270 degrees. All right, let's go back to what the rule said. The direction said 90 degrees, and I wanted to go clockwise. Let's see if what we did, 270 counterclockwise, gives the same point, 11, negative 2. That's exactly what we've got there, 11, negative 2. And you can see then, basically what we've done is that we started with this point A, and we wanted to go this way to get A prime. That's 90 degrees clockwise. But our rules made us go this way, 270 degrees. But it gets to the same point because of the circular nature. Okay, so that's good. So we got 11, negative 2. The next thing it wants to do is, so what are the coordinates of A double prime if we reflect A over the vertical line that passes through P? Well, okay, if I've got a vertical line that passes through P, so let's get rid of this circle real quick. Let's put a vertical line that passes through P. So there's the vertical line that passes through P. If I want to reflect A prime over that, it's going to go, so right now, basically all I'm going to do is I'm going to do that difference between 11 and 6. So that difference is 5. So that thing's 5 units away. So then I'm going to go 5 units this direction. And it should put that point right here at 1, negative 2. So if I reflect this across that line, you see that A double prime goes to 1, negative 2. So that's what I would type in that second box here. Okay. Now it says to apply the translation rule that would get A double prime back on top of A. Okay. So now I'm just going to say, well, what do I need to do to move A double prime so that it lands back on top of A? Well, the idea there is that I'm going to take the x value of A double prime, and I'm going to add 1, 2, 3, 4 values to it. I'm going to move it to the right 4 units. And I'm going to take the y value, and I'm going to go 1, 2, 3, 4 units up. So in that case, it'd be x plus 4, comma y plus 4. Okay. So let's see. I think I can do that here. I can take A double primes. Let's see. Let's go. The x value of A double prime plus 4, comma the y value of A double prime plus 4. And when I hit enter, the hope is that the point that I generate will be right on top of this one here. So let's see if that happens. And you see that it put that B right on top. Okay, so that's kind of what we're looking at there in that problem. Obviously, you're going to be using these points a little bit different. Okay, but the structure and strategy is the same as you work through those. Hopefully that helps. If you got any more questions, don't hesitate to ask.